So I just wanted to talk a little bit about elegance in problem solving, and in particular we're going to focus on physics problems. So students in physics, when they receive a problem that gives them certain numerical values, they have a habit of wanting to immediately start to plug in these numbers. Let's say they give you a problem of, okay, here's a boy on a motorcycle. The boy is 60 kilograms. He weighs 60 kilograms. He goes from 0 meters per second to 10 meters per second, and over a distance of, say, 5 meters. Calculate the total work that the motorcycle does. So a lot of students instantly go, okay, I know what to do. I want to first find the acceleration of this object. So what I'm going to do is look at my equations. I want to use the third kinematic equation, which is v final squared equals v initial squared plus 2ax. I'm going to plug in right away. So 10 squared equals 0 squared plus 2a is what I'm looking for, times 5. That's going to give me a equals, let's see what it is, 100. So it's going to be 10 meters per second squared. I'm good. I'm going to keep on going. So I would suggest at this point we want to change our habit of just plugging in the numbers right away and actually keep these in variables. So I'm going to take out this step. And I'm just going to rewrite this equation in terms of a. We do know that this is 0, so we can disregard this. But let's keep the rest in variables. So what do we have here? We have a equals v squared over 2x. I'm just going to keep it like that and keep on going. So in the problem, we want to get a because then we can get force from F equals ma. And let's keep that in variables too. If we knew this was 10, the next step that some students would take is, okay, m equals 60, 60 times 10, 600, so we're getting 600 newtons over this distance. I would suggest keep this in variables so we can see what happens to understand the relation of variables to each other. So we're here without having plugged in any numbers yet. And then the next step in this problem is actually to calculate the work over that distance, which is force times distance. If you had already known that the force was 600 newtons, you would just say 600 times 5 meters gives me 3,000. I'm done with my problem. What's next? But you've missed like a key conceptual realization here, is that if you kept it in variables and now you plug it into here, mv squared over 2x times x, because d is this distance. Look, these variables canceled out, so you never needed to plug 5 into your calculator ever in this problem. And notice that what you get actually is kinetic energy. So this starts to tell you a lot about the relationship between work and kinetic energy, and this is an insight that you could only get by keeping your equations intact and not putting numbers in. Here we start to see that the answers you get to the solution doesn't just exist in this problem. You now have this formula that you can take into a broader understanding of work and all their problems. So I would suggest that when you're doing physics problems, don't plug in any numbers, work entirely in variables and substitute variable expressions into other formulas until you get to the very end of what you want to do. And then there, you can plug in the numbers just one time into your calculator. So 60 times 5 squared, you get the same value, 3,000 joules, but you've also added a huge amount of understanding to physics.